Hello and welcome to this Online College of Coding video tutorial series. This is the 7th video of the Intermediate Breaky Blocks in Unity series. In this video, we're beginning the final polishing process as we come close to the end of the project. Before starting this video, it's recommended you've seen the previous videos in the series, as well as the Introduction to Unity videos and Intermediate Programming Concept videos. Let's get started. Okay, we're nearing the end of the game. Surely there can't be that much more stuff we need to add to Breaky blocks. Which is true. All we need to do now is basically just polish it off. What we're going to get started with is controlling the ball's speed, adding a bit of difficulty into the game. Let's open the ball script in MonoDevelop and add some code. The variables difficulty and difficulty inc are what we'll use to manage the increasing difficulty of the ball. The difficulty variable is the running count of the ball's difficulty, a higher difficulty variable, more difficult ball, and the difficulty inc is how much we are increasing that difficulty by during the game. A higher difficulty inc value means the game will get harder quicker. Inc stands for increment because we increment the difficulty with this variable. For a significantly more in-depth explanation of the maths and some of the variables used in this little section of code, including the time.deltaTime variable, go and check out the document. For now though, save your script, return to Unity, and let's test the game. When testing your game, if you can click on one of the balls in the hierarchy, then watch the values in the inspector, you'll see that the difficulty constantly increases. And if you increase the difficulty inc variable, the difficulty increases faster. The longer you keep a ball alive, the faster it moves. Next, we're going to add some excitement to the spawning of our bricks. At the moment, our bricks just spawn in solid rows to make one big solid block. We're going to add variations to this block of bricks by randomly creating holes, or in other words, randomly not spawning bricks. Let's open up the Brick Manager script to modify the code responsible for the brick spawning. To control the amount of holes we spawn, we need a variable that can store a percentage. A value of 1 will mean 100%, and no bricks will spawn. 0 will be 0%. And no holes will spawn. By using the range attribute, the value will appear as a slider in the inspector. In the spawn brick row function, we now add an if statement that encapsulates the code in charge of spawning each brick. Within the if statement, we're generating a random number between 0 and 1, comparing that to the no spawn chance variable. If the statement returns false, then a hole will be left and no brick will be spawned. Save and close your script and return to Unity. In the prefabs folder, select the Brick Manager prefab. Then in the inspector, drag the no spawn chance slider, or use the text box on the right, to set no spawn chance to about 0.2. With that value, we're giving each brick a 20% chance not to spawn, and this works out to be a pretty good number to spice up our Breaky Blocks game. Next, we should add some sort of scoring to our game, so every time you break a brick, you earn some points. In the hierarchy, click the Create menu and then choose Create Empty. Use the inspector to name the new empty game object, Score Display, then reset the transform component. Also using the inspector, click Add Component and then choose a text mesh from the Mesh category. In the Mesh Renderer component, turn Cast Shadows to off and untick Receive Shadows. If you can't see these settings in your Mesh Renderer, you'll find them by expanding the Lighting section. Within the Text Mesh component, type in 4 zeros to represent an empty score. Set the character size to 0.1 and change the anchor to the lower left. We also need to set the font size to 100 and lastly change the transform position to be -5 on the x-axis, -5 on the y-axis and 0 on the z-axis. By enlarging the font and using smaller characters, we increase the resolution of the text. The final font we want to use though isn't the one we're currently using. We need to import that as an asset package. We want a custom font instead of the Unity default. So, drag the font asset package into your project browser, and in the import window, you'll see there's a font file located within. With the score display selected in the hierarchy, drag the new font from the fonts folder in the imported assets folder into the text mesh component in the inspector. Click the Add Component button in the inspector, then choose New Script. Name the script Score Display and make sure the language is C#. Click Create and Add, then as usual, move the script to the scripts folder of the project browser, and open it in MonoDevelop so we can add some code. The score display class is just a tool that we're going to use to change an integer representing the score into a string for the display in our game. The class needs a link to the actual text mesh component of the game object we just created before, which we assign in the start function. We then have a static function that we can call from another script. The function takes an integer parameter and simply converts it to a string, then sets it as the new string to be displayed on the score display in the game scene. Now switch to the Game Manager script. Our Game Manager script is the best place to create the variable that will hold the score for our game. But because the place that will end up incrementing the score is the brick class, the score variable needs to be static. In the Game Manager setup function, we need to set the score to be 0. This will happen each time the player enters the game state. After we've set the score variable to 0 in the Game Manager script, we then need to move to the brick script where the points will be added. Each time a brick is broken, some points will be added onto the score variable. This is why we made it a static variable, because we need to be able to access it and use it without creating another instance or getting a link to it. This is where we call our static function display score. We're going to use this at the bottom of the brick's break function just before the game object is destroyed. The integer representing the amount of points awarded is calculated as a random number between 100 and 115. We then use the plus equals operator to add the random number onto the current score variable all at once. Now return to Unity and test out the scoring. Last but not least in our list of things to polish is reducing the spawning of the red and purple bricks. This can be done pretty easily just with code we've already used throughout the project. After each brick is created, we're going to see what material it's been assigned, and if it's red or purple, we can simply choose a different material. Currently in our game, before adding this code, the odds of getting a special brick are 2 in 5, or 40%. After we add the code, the probability changes to just 8%, which makes the red and purple bricks feel like much more of a reward for the player. So open up the Brick Manager script and get typing. The code's just going to be a simple check of the brick's material name against a string we provided, which is the material name in the project browser. It's important that the string here is typed out exactly the same, with capitals and spaces exactly the same. If they match, then we just re-roll the random value to choose a new material. Jump back into Unity and hit the test button. You'll see way more green, blue and yellow bricks than red and purple. It looks like our code's working. Now, I know I said that was the last thing we were going to polish, but we do have one more thing to do, and it's not technically polish. But before we move on to doing sounds and camera effects, we want to add a trail to our ball, a little tail. Drag the ball prefab from the project browser into the hierarchy and double click on it to zoom in. Now in the hierarchy, right click on the ball and choose Create Empty. This is going to be the game object that manages the trail, so we'll use the inspector to name it Trail. Click the Add Component button and select from the Effects section a trail renderer. Set Cast Shadows to off and untick Receive Shadows. Then next, we need to choose a texture for the trail, which is going to require us to import an asset package. The asset package also has a few other resources we'll need as well. Drag in the ball trail asset package and click Import. We can find the texture that we just imported in the Imported Assets and Art folder. Then go into Effects and you'll see Ball Trail. Select the trail game object and drag Ball Trail into element 0 of the materials list of the trail renderer. For the rest of the settings, we need to set the time to 0.5, the minimum vertex distance to 0.05, and the width to 0.25. Then right-click on the graph within the trail renderer component and choose Add Key. We need to drag this key to the bottom right corner of the graph. Now if you look at the shape the red line's making, this is going to be the shape of our trail over time, starting at 0.25 in the top left and going down to 0. So feel free to add another key or two to this graph to personalize your trail. Next, we have to choose a color for our trail, and by way of the Unity Color Gradient Editor, we can choose lots of colors for our trail, and in just the same way that our trail is going to use the red line graph to get smaller over time, it's going to use the Gradient Editor to change color over time. Now, the Gradient Editor is a little bit hard to explain, So if you just make yours look like mine, you can pause the video to watch what I'm doing. There's pointers on the bottom that choose a color at a point in time, and there's pointers on the top which choose a transparency at a point in time. So we're going to make our trail change colors over time and also change transparency over time. The last thing we have to change in our trail renderer is the light probes and the reflection probes. Set them both to blend probes. This just affects how the texture for the trail will show up in the scene. Now select the ball in the hierarchy, then click the Apply button in the inspector to save our changes to the prefab, then delete it from the hierarchy, and test it out to see what our trail looks like. As the ball moves, the trail hangs around behind it, but it looks a little bit still and stagnant. I think we can breathe some more life into it with an animation. Lucky for us, there was an animation in the ball trail asset package. All we have to do is select the ball prefab in the project browser, then select its child object, trail. Scroll down in the inspector and click the Add Component button. From the Miscellaneous section, choose an animator component. Then click the circle to choose a controller for our animator component, and in the options, select the ball trail animation controller. And it's as simple as that. Go and test the game again, and check out the new animated ball trail. I'm not sure if you noticed, or if you're having the same problem as me, but my bricks weren't actually moving at all for this entire video. I think I accidentally quit without saving my Unity project. But the fix is simple. All you have to do is go to the Brick Manager prefab in the project browser and change the brick movement speed variable back to 0.035. Now that that's sorted out, that's part 7 completed, with only one more part to go, where we need to bring our game to life by adding sound effects and even a camera effect. See you then.